Hello, my friends, and welcome back to Alien Protocols. Here's our wonderful logo. The original design for it is from Artsy Dude, just an incredible artist if you need an art director for any of a range of your art needs. The Nobel Prize was issued recently for physics for several gentlemen who proved non-locality. And it's a little more complicated than that. They proved something, but the theory behind it that is propagated is incorrect, in my humble opinion, and I think time will bear me out. I've spoken about this at the very beginning of this channel. You can go back and see some videos. And our logo really kind of captures it wonderfully. Let's consider the Big Bang all the way down here somewhere, okay? And as events happen, there's a branch, like a tree, there's a hub. And let's say you're here, and this is the now slice right here. This is the now timeline. So I guess time would be going up like this, and space would be going like that. So we have two different particles, or two different people, or whatever, separated by distance in the now slice, okay? So, and here is there. Let's say this distance between here and there is 1 light year. And that is the distance light travels in a year, of course. And there's been a big confusion and a huge mystery in physics as to when you create two particles that are like one, and this is referred to as entangled, when the two particles become so empathetic that they're really kind of one superparticle. They can be in two states simultaneously, some people say. But so let's get these two entangled particles, and they travel over time different places. Okay? And there's this spooky action at a distance that Einstein hated, and this is what it's all about. If you measure this particle, this other particle over here will instantly change to the exact opposite of that first particle. They're entangled. Like a positive and a negative, you need both to kind of have one reality. So what happened is this particle split, and one is here, and one is there, and what Einstein didn't like is that if you measure this one over here is instantly becomes the opposite. And Einstein called this spooky action at a distance because the information somehow traveled from here to there that this one was measured, and so this one has to reveal it's the opposite. It can make that communication faster than the speed of light, and Einstein thought that it was impossible, and that somehow there was a hidden variable, a hidden reality that science didn't know yet, and that the information about this decision here, who was positive and who was negative, who was yes, who was no, who was here, who was there, this decision was already made back here somewhere. That was what Einstein believed was happening, that there was a hidden variable. And many experiments have found out that before you measure the first particle, it has not become one or the other yet. It hasn't essentially been solidified into reality. The decision hasn't been made which one it is. You would think it already was what it was, and this one was what it was. But many experiments prove that their decision is almost the way you can describe it. The decision to be positive or negative isn't made until it is measured or observed, the first one. And this is called this entanglement aspect. And it's also called the uncertainty principle. You cannot be certain about the states of many of these quantum particles until measured. You can't even consider them existing unless they are measured or observed somehow. So the big confusion, and the Nobel Prize basically was awarded for proving that the decision had not been made yet between here and there, or plus and minus, over this vast distance. It hadn't been made yet until one was measured or observed. That there isn't a hidden variable. The information wasn't sneakily inside and we just couldn't find it, like Einstein hoped. That's what these guys got their Nobel Prize for. But essentially what happens at every event is there's a probability curve like this. There's a range number of reasonable and unreasonable options of things that can happen. The universe has this pre-programmed. There's a range of possibilities. So when a random event has to happen or an outcome has to happen, the universe essentially rolls a dice, and the most probable events are going to be up here somewhere, but the weirder and less probable events are going to be down here. And once it's measured, this quantum system, this probability curve disappears and it becomes a real particle. It solidifies and then becomes part of the structure of the past. Kind of like this tree. One big bang right here, all the chaotic and particles, things start happening, branching, differences, dice are being rolled essentially, decisions are being made, and we live on this slice at the very top, kind of like this. So what's really interesting, I think, and the idea that I've had, and I presume a bunch of other physicists have had, is that the universe is very efficient and likes to get things done the most simple way possible, the most logical and simple way possible. The universe loves efficiency. It loves it. And because of that, there is this whole, things aren't really there until they're measured or observed aspect of our universe. That is more reasonable than filling in places that haven't been measured or won't be known. It's a waste of matter and space and time. So what the universe does is at this moment, when you measure this one, the dice is rolled, whatever outcome it is, and that change affects the past. It's a retrocausal effect. Just by measuring this one, sends a message backward in time to the moment that they were both entangled. And it lets them both know who they are. The decision has been made, and they can be a slice of reality. A now slice, let's say. So, I think the Nobel Prize was wrong in a way, that there is a hidden variable and it's retrocausality. There is no faster than light communication.